Hello and Assalamualaikum. We are from Group 74 and we will be presenting our case study on Flint water crisis. The Flint water crisis took place in 2014 in Flint, Michigan, USA. The city made a cost-saving decision to switch its water supply from Lake Huron to the Flint River. However, they failed to apply corrosion control treatment, which caused lead from aging pipes to leach into the drinking water. This exposed over 100,000 residents, which many of them are children, to dangerous levels of lead. This crisis didn't happen by accident. It exposed deep failures in engineering responsibility, public governance, and ethical decision making. Right after the switch, residents noticed foul-smelling water and started reporting health problems like rashes and hair loss. Despite clear signs, the government denied anything was wrong. It wasn't until 2015 that researchers from Virginia Tech and Dr. Hannah Atisha confirmed the water had high levels of lead and that children's blood lead levels were rising. Flint is a low-income, majority black city, and the slow response revealed systemic injustice. Many believe this would not have happened in a wealthier area. This crisis wasn't just about contaminated water. It was about ignored voices and environmental racism.
Hi, my name is Praskashila from Petroleum Engineering Department, and in this project, I will cover the technical and engineering reasons for failure in the Flint water crisis. First, the switch from Detroit treated water to the untreated Flint River was done without adequate technical assessment. The Flint water treatment plant was not prepared to treat more corrosive river water, and this cost-driven decisions was made without considering the system readiness or safety. Second, the aging water infrastructure, mainly lead and iron pipes, was never evaluated or upgraded. Engineers failed to assess whether the new water chemical properties were compatible with these materials, and this violated the fundamental engineering responsibility to ensure the infrastructure is safe and resilient before making operational changes. Lastly, the corrosion control treatment was not implemented even though it is a standard requirement under the United States Environmental Protection Agency's EPA lead and copper rule. Without corrosion inhibitors, the river water's high chloride content accelerated pipe degradations, causing toxic lead to leach into the water supply. These technical oversights, compounded by poor decisions making, demonstrate how failures in engineering judgment can lead to widespread harm, especially when the regulatory standards are ignored and infrastructure conditions are underestimated.
Ethical reasons for failure. First, Flint's water supply was switched to cut costs, even though the officials knew the river water was unsafe. They hid contamination data and skipped essential staff training, testing, and plant upgrades. Second, they failed to add corrosion control chemicals despite knowing the risk of lead exposure. pH levels weren't monitored properly and chloride level was increased, making the water more corrosive and dangerous to health. Finally, the water testing process was deliberately skewed. Only 60 samples were collected instead of the required of 100 samples. Residents were told to flush taps before sampling, which reduced the detection of lead, and high-risk homes were purposely left out.
For Flint water crisis, here are three proposed recommendations to prevent future problems. First is replacement of lead pipes. Example is in Madison, Wisconsin, where the officials identified excessive lead levels, which prompted them to take measures for $15.5 million, which is less than the cost to fix Flint water crisis. In relation to RA 1967, Section 24 1B and C requires engineers to make actions upon seeing hazard that may harm public. Second recommendation is overhauling water sampling protocols, which was successful in Washington, D.C. It can capture lead release pattern more accurately, and now Michigan has mandated to use 5-liter samples in their sampling method. This relates to Section 23 of REA, where engineers need to conduct themselves ethically and responsibly to ensure the sampling reflects the actual hazard going on. The third recommendation is for engineers to practice escalating concern when they see potential hazards for public. Example, in Flint water case, the engineering firm Land Incorporated should have notified the regulatory bodies when they see absence of corrosion treatment. Engineers should place public safety above all as per REA Section 24 1B. And these are the three recommendations that we propose.
The Flint water crisis shows what happens when engineering ethics and public safety are ignored. It's a reminder that engineers must speak up, act responsibly, and always put people first. Our decisions affect lives, and protecting the public must be our top priority. That is all from us. Thank you.